For our next topic and example, we want to conduct a hypothesis test, and then we also want to see the difference between statistical significance and practical significance, because they're not the same thing. And we'll see that hopefully illustrated in this example. All right, so in Canada, the average age of a patient admitted to the intensive care unit in 2000 was 64.5 years old. A hospital administrator believes that the age of ICU patients has decreased since then. They gather a sample of 6,018 random ICU patients over the period of a few years and find that the average age to be 64.28 years with a standard deviation of 8.2 years. Are these results statistically significant at the 0.05 level of significance? All right, a couple things. Remember, statistically significant, those words mean do you get to reject H naught? Right, that's your goal. And then I also like these words where it says assume the conditions are met. See that? So when it says assume the conditions are met, that means that we do not verify conditions. They're given to us as already met. So we don't have to worry about them. Or requirements, they're the same thing. Requirements, conditions, ignore them, right? Don't worry about them. Well, that's nice. That's some work right there that we don't even have to deal with. Always lovely. All right, so step 1, H naught and H1. Now, this is obviously about the mean. I mean, for one thing, it's talking about the average right there. And for another thing, there's no percentages in any of this. I mean, it has mean and average written all over, well, average written in a couple places. So that's a sign that it's a mu one. Right? It's not a survey, right? It's a sample of 6,018 patients, and they were finding their average age. All right, so we assume that the mean is 64.5 because that's what it was in the past. That can throw a lot of students as how do you know which one to assume? The past tends to be what's assumed, the farther past, right? So these are both in the past, but this one's farther in the past, right? So whichever one's in the farther past, that's the one that's H naught. So that means it's 64.5. And that means this number is also 64.5. It's going to be the same number for both of them. All right. And now the hospital administrator thinks it has decreased. See the word decreased right there? That means less than. All right, lovely. So H naught and H1 are done. Step 2, alpha. Alpha is 0.05. Given to us right there. Right, that's your level of significance. It's the probability of a type 1 error. Step 3, T0 is x bar minus mu 0 over s over the square root of n. So I show that formula, right? And then I have to find out what all those values are. Well, mu 0 is 64.5. It's the value you assume in the zero hypothesis. So that's done. And then x bar was right here. Let me see if I can highlight it for you. Average age is 64.28. See that? That's x bar. So 64.28 goes here. N is right here. There's n. Right? So that would be 6,018. So I'm going to put a little division and a square root there. And then S, I'm running out of colors. S is right here. There's S. 8.2. Okay? So actually, I don't even think I have to say that part. I can just say S and you'll know what I mean. So it's 8.2 right here. We are so not going to do that by hand. We are going to make StatCrunch or the calculator do that. All right, so let me go to StatCrunch first. I'm actually going to leave it over here on this small bit. I can do it on any particular blank StatCrunch page. It can be this page with data in it. It doesn't hurt me. Or I can go to a blank page. It won't make any difference. So I'll go to a blank page. That way you don't get confused. So if I go to Stat, I'm going to choose T-Stat just like before. One sample just like before. Now let me make this larger just so you can see the menu system a little bit better. So Stat, T-Stat, one sample. Now, data would mean I have a column of data, which I do not have in this problem. There was no table given to me, no data table. So I'm going to choose the second one, which is with summary. So I choose with summary, and it wants the sample mean, which I'm going to shrink this down so I can see my values. My sample mean was 64.28. My sample standard deviation, that's S, that's 8.2. My sample size was 6,018, which is a huge sample. And now I've got to tell it my hypothesis values. My hypothesis values were 64.5, and it's a less than. So I'm going to type 64.5 right here, and notice it automatically makes the second one 64.5. And I want to choose a less than. And I click compute. And there's the value right there, negative 2.081. Simple as that. All right, now on the calculator, do the same thing. I would go to Stat, Test, T-Test. We don't have data here, right? There is no data table given. So I would choose Stats, Enter. And then I'd have to enter all these values. This was 64.5. This was 64.28. This was 8.2. This is 6,018. And I actually want to choose a less than on this one, because that's a less than for my alternative hypothesis. You can see it right there. So I want to go to the middle one with my arrow and press enter. That way it's dark when I move off of it. And again, ignore the color thing, don't worry about that. And press enter for calculate. And you can see your test statistic is right there, negative 2.081, just like StatCrunch found. And also you can see your p-value for our next bit, which is 0.0187. All right, so that's how to use both of those. Use whichever one of them you like. It makes no difference. Right, it'll be fine either way. All right, so this was negative 2.08, if I remember correctly. Should have left my StatCrunch up there so I could see it. So negative 2.081 right there. So that's that value. So now when I draw my picture, I want to draw a left-tailed picture. So it's going to be this picture right here, and that p-value that's going to be labeled is 0.0187, which is coming out of StatCrunch. Okay. Now how far over do I want to shade? Well, I want to make a T-curve. So make a nice T-curve. Doesn't have to be super huge, right? It just has to be a little nice T-curve. Remember, zero's in the middle. There's -1, there's -2, so negative 2.08 is right there. And that's T0, which is negative 2.081. Yes, you label it. Then you shade the tail, and that's your p-value, which is 0.0187. Right out of StatCrunch or right out of the calculator. Either way, 0.0187. Step 4 is done. Step 5, we need to make a decision. All right, so our p-value was 0.0187. Our alpha was 0.05. That is less than that, so we will reject H naught. So these results are statistically significant. I'll make a little note. Right? That's what we just proved, right? Rejecting H naught means statistically significant and vice versa. And just to finish it out, since we're doing the hypothesis test, there is sufficient evidence to support the claim that the mean age of ICU patients, and this is where all the work is, right? What are they talking about? So is the mean age, is the average age of ICU patients is lower than 64.5 years.